Hi-ho, redox practice is still here, and we've seen questions before where we were building a table of half reactions and putting them in order. Now we're doing that again, and they're asking us to also figure out the voltages for every half reaction as we do it. So here we have mystery elements X and Z, and this is a mystery element also. This cannot be phosphorus because there is no diatomic phosphorus. It's normally P4 or even P10. So these are unknowns that aren't going to be in our data book. So the only way to get started with this one, as far as I can see, is we have this reaction involving lead oxide and sulfates and acid, which is in the data book. This is one of the reactions that takes place in a car battery. It's called the lead-acid battery reaction. And so all of this stuff, if you look in your data book, you will find this in the second from the highest row. Right there. So you take solid lead oxide, mix it with sulfuric acid, that gives you the hydrogen and the sulfate ions, and you form lead sulfate and some water, and you get a nice chunk of voltage. So that reaction we get for free. The data book gave it to us, and I'm just going to copy it out by itself. PbO2 plus a sulfate plus 4 hydrogen. Oops, sorry, plus 2 electrons. I hear those are important in electro. Though admittedly not super important when you're just calculating voltages. Plus 2H2O. And according to the data book, that gives us 1.69 volts. Now, the other side of the story in this first reaction is right here. We have X turning into X plus. Either these should both have 2's or neither of them should. That's a glitch, but it's not going to matter for our voltage calculations. And if we're getting 1.69 from the lead plus something for this reaction and the total is 2, then this reaction must be giving 0.31 volts. Makes sense? 1.39 plus 0.31 explains our total of 2. But if we're doing a table of reduction half reactions, we wouldn't put it like this. Our X reaction would start with X plus, and then it would gain an electron, and we'd produce X, and the voltage for that would be, since we flipped this, negative 0.31 volts. Good there? Now that we have that, this next reaction involves X's turning into X pluses, the reverse of the reaction we have here, and Z2 ions reducing to Z, so we have more calculating to do. Here we have X turning into X plus. What would the voltage be for that? Don't say minus 0.31. We're starting with X metal, we're going to X plus. That's the reverse of what we have here, so this would give us positive 0.31 volts. The other side of this story is Z ions turning into Z metal. That's producing some amount of voltage, and the total is 0.19. 0.31 plus X is 0.19. This reaction must be giving us negative 0.12 volts. And this one is written in the order it should be in the data book, with the positive on the left, then it gains electrons and turns into Z. So we could say Z2 plus, throw in the electrons. This looks like a proper half reaction. Turns into Z, gives us negative 0.12 volts. All right, and now that we have that one more step. In this last reaction, we have Z turning into Z2. Z turning into Z2. That's the opposite of this reaction, so we'll get the opposite voltage, 0.12. The other side of this is we have P2, whatever that is, turning into 2 P minus ions. That's producing some voltage, I don't know how much, and the total is 0.88 volts. 0.12 plus something makes 0.88. This reaction must be giving us 0.76 volts. And I'm sorry, this should have electrons in it. So, on our redox table, P2 plus 2 electrons turns into 2 P minus ions, and the voltage is 0.76. Now, this isn't much of a redox table if it's all out of order, so you could recopy it, or I'm going to take advantage of my select and drag ability here and say this X half reaction is the one with the lowest voltage. So we'll put that at the bottom. This 0.76 is the second highest. That should go there. And yeah, that should do it. Highest voltage down to lowest. Everyone has electrons on the left. And I think that is all sorted now.